Okay, so let's look at an exam preparation and revision for the AWS Certified Cloud Practitioner. So the Cloud Practitioner certification builds from the AWS Cloud Foundations. So if possible, it's best to study through the AWS Academy and get access to both the knowledge base and the practical environment. So here's my environment here. So this gives access to a lab environment with the CLI, the SDK, and also for the management console. So as much as possible, you need to get hands-on practical experience of compute, data store, Lambda, networking, and so on. And really, the material becomes alive when you actually do practical work within AWS. And luckily, within AWS Academy, it is possible to get a credit for the labs. Okay, so the Cloud Foundations Cloud Practitioner certification is an external exam that is a proctored exam. You can pass the AWS Academy Cloud Foundations and receive a badge for that, but the main certification is taken through an external exam. This then leads on to 3 different routes depending on the career preferences: developing, architecting, or cloud operations. And then again, that leads on to certification around development, solutions architecture, and SysOps. So the AWS Cloud Foundations course builds into 10 main units. Overview, billing onto the global infrastructure around regions and availability zones, through cloud security, very important module this one for the exam, networking and content delivery, then the core compute storage databases, onto cloud architecture and scaling. Really a great introduction to cloud computing overall, and we just happen to be using AWS to implement this. But everything we learn can be scaled easily into other cloud infrastructures, public cloud infrastructures. So you should find that there is an online link that you can go, and you need to get registered and set yourself up for the exam. You then book the exam, and you give yourself at least 30 minutes before the exam to get all set up, because there will have to be identity checks. The exam itself has 65 questions, and that's taken over 90 minutes. There is a next and previous, so you can go back and forward at any time, and you can flag questions, and also there is a review at the end to make sure that you're happy with all your answers. With me, I went through the whole 65 questions in 30 minutes, paced myself, and then I went back to start again and took another 30 minutes to go through the questions again and read them. Remember that 1 or 2 marks questions can make all the difference between a pass and a fail. So just make sure you've read all the questions and you haven't stumbled and made silly mistakes there. So for the study, there is the formal study guides that are provided by AWS. They cost about $29 a month, but you can cancel the subscription at any time. And there are exams that can be taken there that are just like the certification exams. There's also exam cram software and books that you can study from, and this is the main certification here. So make sure you cover as many of the questions as possible. You keep training and learning the right answers. Don't take material from the internet that has wrong answers, or you'll end up having the wrong answer in the end. So there are 4 main areas within the exam: cloud concepts, security and compliance, a very important area, technology, that's probably the biggest area, and then billing. So each of the questions will fit into these core study areas. Okay, so you need to understand roughly what each of these areas actually do. EC2 is obviously the core compute infrastructure. We have an AMI and we create instances from that, EC2 instances. Lambda is our serverless computing, where we can run scripts. So rather than being charged per hour, we can be charged only for the amount of time that the Lambda script runs. If possible, we loosely couple our Lambda scripts together. Elastic Beanstalk allows us to automatically create a web infrastructure that we can easily deploy and scale. EC2 scaling allows us to be able to scale in and scale out. Is defined as out and in within our scaling infrastructures. We compute power in to cope with higher demands, and we compute power out to be able to reduce our compute power. Then we have the elastic component services here, Docker and so on, Kubernetes for load balancing, and then we have a registry for our component services. And then finally we have Fargate, which allows us to create components, Docker components and so on, that get charged per second. When it comes to identify security, identity and compliance, the core one is obviously AMI, and with this we create users and then we create roles. So users are assigned into roles. We can't nest these roles. We have a role and then we assign the users into it. And that provides the core of the access rights. And we want to make sure that we provide the right rights to the right role for any given task. Cognito allows us to be able to log in with federated login, such as we could log in with Facebook and get a token from Facebook and then provide it to our AWS service, and that would allow us to be able to log in through Facebook rather than using our AWS credentials. Shield allows us to protect against denial of service attack. Artifact will come across later, but that allows us to keep our audit compliance documents in one place. And KMS is a very important service for our key management system. There we can create symmetric keys, public key pairs. We can digitally sign and create HMAC signatures too. So KMS is a good place to be able to create keys and also to perform our encryption. When it comes to storage services, we can use an AWS managed data infrastructure called S3, Simple Storage System, and that stores data as objects. So it's very good if we have documents and data elements. We can store any type of data element within our S3 bucket, and it's almost unlimited the amount of data that we can actually store. If we don't use our data objects that often, we can put them back into Glacier Store. It takes longer to be able to access the data objects, but it's much cheaper. So normally what we would do is we would have a policy to put our data objects that are well used into S3 buckets, and then automatically those that won't access that often would get put into Glacier. And we can have different levels of Glacier, and each one is less expensive. There is one option that allows us to put into a deep freeze, where it would take up to a day to be able to get our data back again. So that's very good for a complete backup of a system, just in case we lost all our data. Then we have two data storage systems. The main one that we would mount onto our EC2 is the elastic block storage. EBS. That's just like a disk that you would mount onto a computer, and is based on blocks. The other one is the elastic file storage, and that's like NFS, where we can actually take disks and then mount them and allow access to them over a network. So this EFS is used for network file system type infrastructures, and Linux, for example, supports, every version of Linux supports EFS for that. For EBS, we pick usually the disk type based on the operating system. Then when it comes to database systems, we have RDS, which is a managed database infrastructure that supports MySQL, Oracle, and so on, and it's based on a relational database type structure. For a NoSQL approach, we use DynamoDB, and this allows us to be able to create data objects or data blobs defined in a JSON format. Redshift, as we'll find later on, allows us to create data lakes. That's for massive amounts of data. And Aurora we'll come across a little bit later, but that's more an enterprise infrastructure where we might migrate from RDS towards Aurora. When it comes to networking, we have our virtual private cloud, and at this level we can create our networks, we create our subnets, we then have what are called security groups and network ACLs to be able to define the traffic that flows across these networks. And we can also have routing tables, and we can have gateways onto the internet or into other networks within our VPC. Route 53 is the DNS service, and it allows us to resolve a domain name into an IP address, but we can also do failover from one server to another if it goes down. CloudFront allows us to be able to place our content as close to the customer as possible. So we might have a server in one region of the world, say in London, but we know that our customers are in Japan, so we can actually place the content as near to Japan as possible. Elastic load balancing allows us to be able to balance on a geographical area, so we can actually make sure that our content is delivered in an efficient way. When it comes to management and government services, a trusted advisor is a good way for us to be able to see what's happening with security, billing, and so on. CloudWatch is our basic place that we see all of our logs. So we might monitor CPU or memory of a server, and this will give us a place that we can add our alerts. So we might want to alert when the CPU was over 90% for 4 hours. We can do that with inside CloudWatch, and it'll show us our alerts. CloudTrail is when we want to be able to see a user and to be able to trace the user's activity through our systems. Well-architected tool we'll find is a useful method to give us advice on how we can create secure, scalable architectures. Auto-scaling allows us to be able to scale up automatically. The CLI we've came across before. I showed you the CLI, where we can have commands that can be entered within the command line interface. Config allows us to store configuration files so that we can actually script our operations. The management console I've shown you before, and that's our main graphical user interface to be able to access our services, but everything can be accessed from the command line too. And AWS organizations allows us to take multiple organizational elements or departments and bring them together into a single billing infrastructure. And finally, and just as important as all the rest, then we have AWS Cost and Usage Reporter, which will give us a breakdown of where our costs are, budgets, and also Cost Explorer. So let's go into some of the key areas. Module 1. Module 1, cloud is pay-as-you-go and no upfront costs. It can go at different levels. Infrastructure as a service is where we have EC2 instances, but we can go right up to platform as a service. But really we start at infrastructure, and AWS will look after the network infrastructures and the hardware for us. It's elastic balancing, and we use virtual private clouds to be able to implement our networking. ACLs, security groups, and identity and access management allows us to be able to implement security at a granular type level. One of the core advantages of AWS is that we can go global across the world within minutes. There is also economies of scale, and it's possible to be able to reduce costs because of this massive scale up, and to be able to use computing power, networking power, and data power to reduce costs. So basically, when a company moves from on-premise to the cloud, they're moving capital expense. That's really a commitment to buy hardware into variable expense inside the cloud. For networking, we have elastic balancing and VPC, as we outlined, and then network ACLs and IAM are our core ways that we can control the security. So global in minutes, massive economies of scale, trade expense for variable expense are the core areas that we see there. So when it comes to the 6 advantages of cloud: trade fixed expense to variable, benefit from economies of scale, stop guessing your capacity and what you need and try to understand what you require, increase your speed and agility and the time to market, stop spending money and maintaining data centers, and go global in minutes. Can't say that so many times. Very important point. Go global in minutes. The compute services, EC2, Lambda, Fargate, Elastic Beanstalk that we've actually covered. For storage, it's S3, the elastic file system, and the elastic block storage, elastic file storage, we have EFS and EBS. When it comes to the way that we configure, we either configure from the management console, as we saw, the command line interface, or from the SDK, from Python or Golang. When we migrate from on-premise to cloud, we reduce the cost of data centers and physical hardware. We also benefit from increased business agility and can improve the time to market. Along with this, we have elasticity, and that allows us to be able to match the provision with the demand. So if we need more data, we can scale in, or we can scale out. We need more compute power. Again, we can scale in and then scale out. And we only pay for what we actually consume. For application development, reduces capital costs, low variable expenditure, and as I said, scale up in minutes. And we have reduced, for agility, we have reduced times to deploy our applications, so we can go quicker with our updates and deployment of new services. And the migration, then obviously the customer is responsible for licenses and physical security and also power consumption. But in the cloud, physical security, hardware and power are the responsibility of AWS. So an important element is when we're migrating data. So with this, we can take our data from our on-premise and synchronize it into the cloud. 2 core services that we can use for this are AWS Direct Connect, which allows us to be able to connect at a very low networking level between our on-premise and our cloud. This allows for fast and reliant synchronization of data and services. We can also have AWS storage, which allows us to be able to take backups and and large amounts of data and upload it into the cloud. But along with this, there are other services that we can use, including AWS Snowcone, that allow us to be able to efficiently move data from on-premise into the cloud. So cloud economics and billing, very important area, and that's the reason it's the second unit that's covered. Really, if you're not using something, then turn off the resources, because you don't pay for them, but you do pay for the storage. So the disks that you create onto the EC2 instances will get charged. So if possible, try to keep them under a threshold so that you don't get charged too much. Snapshots are also charged too, but only for the difference between the previous snapshot and the current one. But if resources aren't needed, then they should be switched off. You pay per hour typically, or per second, depending on the instance types. There's no upfront costs, and it's all pay as you go. There are no termination costs when you get rid of any of the resources. And the fundamental costs for our drivers are compute, storage, and data transfer. Each are billed for certain rates. There's no charge for incoming data transfers within the same region. So anything that's coming in isn't charged, but obviously data that goes out is charged. If it comes across the region, then it can be charged. Then we'll outline what a region means in a little minute. Data transfer is aggregated across all the services and get charged as a single amount, and it's difficult to see where those data transfers are coming from. It's just all aggregated. To save money, it is possible to reserve resources in advance, and you can pay much less money by reserving an amount of compute power in advance. It is also possible to reserve for between 1 or 3 years, and we can reserve all our EC2 instances with all upfront reserve instances. There's free tier for new customers up to 1 year. We have Elastic Beanstalk, VPC, auto-scaling, CloudFormation, AWS Identity and Access Management are all free to use. And we can aggregate all billing with different areas of an organization into one using AWS Organization. So the billing calculator is useful to be able to estimate how much things are going to cost. And it's there we can actually define what we think we're going to be needing, and then we'll get an idea of our monthly costs from there. Consolidated billing allows us to bring together many accounts into one, and then we can benefit from volume discount thresholds. We can also have economies of scale as we scale up, where the more that we consume, then the lower the variable costs will actually be. The AWS Concierge team will provide support for billing and best practices too. For consolidated billing, we have one bill, easy tracking, combined usage, and there's no extra fee for this too. A trusted advisor, and I'll show you that in a little minute. With a trusted advisor, we can look at cost optimization, performance, security, fault tolerance, service limits, and so on. And it also shows us the regions that have the lowest costs. And we can get alerts based on any of these areas. Trusted Advisor also gives us advice on the snapshots that we have. That's the data snapshots for our disks and so on. CloudTrail gives us an idea of user activity and all of the API calls that a user will call up, especially looking at security. CloudFormation is a templating infrastructure that will allow us to be able to template our designs and then to be able to script them. AWS Organizations, as I said, allows us to create a single bill, and it also allows unwanted accounts and underutilization of resources to be removed. And this is CloudFormation here. What we've got is that we can have what's called code commit, which is a bit like a GitHub. We can have our code here, and the S3 is storing some data here. That can then go into our CloudFormation infrastructure to be able to architect our cloud. Trusted Advisor is something like this. We can see cost, performance, security, fault tolerance, and so on. And it will give us some ideas as to what the recommendations are and if there are any alerts that we have on each of the areas from there. So this might show us when there are outages in the cloud that are forthcoming. We might have some security issues here and general performance issues on our dashboard there. So this is Trusted Advisor. When it comes to billing, we have our billing calculator, and in there we can actually add lots of options, and then we'll get a costing estimate for our compute requirements. Trusted Advisor is here, so this is what we just saw earlier: cost optimization, performance, security, fault tolerance, and service limits. And this will give us our recommendations from them. And then we have a cloud trail, which will watch certain users and see their activity. So we might want to see when a user is logging in, say as the admin or a high-level account. From there we can actually see in some detail what they've been doing. So that's Cloud Trail, not Cloud Watch. For billing, this is a CloudFormation here. As I said, we take our code, we can store our templates for our clouds in an S3 bucket, and then we can actually create our provisioning of the cloud through Cloud Provision. AWS Organizations allows you to create your account, add accounts, and group things together, apply policies to them, and obviously to be able to enable our services. So this is an example here of our root organization, and then we have several organizational units which are added, and with this we then have a policy which is applied to each of the organizational units, possibly for billing and so on. Okay, so that was billing. Now we go on to the global infrastructure. So basically we have regions around the world. So for example, we have North Virginia, and then within North Virginia there is a number of availability zones. So these are AZs, so we might have a US East 1 as the region, and then we can have 1A, 1B, 1C, 1D, 1E, 1F as the availability zones. Data is synchronized for networking and for EBS across the availability zones. So if one of the availability zones goes out, then the other ones can actually provide the data or the networking or compute infrastructure. The data is not automatically synchronized out of the region. It should stay inside the region for our EBS and also for our VPC. Okay. So CloudFront is there so that we can actually have a network, and we can have CloudFront places that will place our data in a cache as near to the edge of the cloud as possible, as near to the customer as possible. Regions are isolated from each other, and data is not automatically replicated. It's up to the customer to define whether there is some replication between regions, but within each region the availability zones will have synchronized data but not outside them. So regions, we have different regions across the world. London, Dublin are two example regions. We have North Virginia, which is a US East 1, each have an availability zone that's contained within the region. These availability zones have data centers with redundancy in them. If any critical infrastructure fails, then we make sure that the data is synchronized across the availability zones in that region. The location of them aren't disclosed, and on failure, they should automatically move the traffic away from the affected area to another area. AWS provides Route 53, which is a domain name service that works across the world. We also have points of presence in most of the major cities in the world, which will give a local presence inside that region. Elastic block storage is used and will be synchronized across the availability zones, but not outside the regions. EFS, the Elastic File System, allows for NFS, or a networked provision, and obviously that can be synchronized across different regions. And then we have the S3 Glacier, that allows for the storage of low cost and low latency data within S3 buckets, typically used for data archiving and long-term backup for Glacier, but S3 is used for fast, low latency access. Glacier is more for a backup. It's much less expensive, but obviously the delay is longer to access it. Lambda allows for code to be run without being provisioned on services, and you only pay for the compute power that you need. So if something is going to run for just a few minutes or a few hours, then it's probably better to run as Lambda rather than as a server. RDS, relational databases, are relational databases that are managed by AWS to create MySQL type databases. So they support MySQL and PostgreSQL along with Oracle. Redshift is a managed service that allows for petabytes of data, or even going up to exabytes, and they're stored in Amazon S3. DynamoDB is a data infrastructure which is an NoSQL approach, and it stores data as data objects. Our VPC, of course, is the way that we create our networks, our virtual private cloud. We can have load balancing, and we can have different types of balancing dependent upon the types of infrastructure elements that we have. CloudFront pushes the data to the edge of the cloud for delivery. And transit networks allows us to be able to connect different customers with their VPC. As we saw, we had Direct Connect, which allows two networks to be connected between two regions. The Transit Gateway allows different customers to connect through a gateway. Okay, so there's a CloudWatch there. It's our core place that we go and send all of our metrics to. So as an example here, there might be an Elastic Load Balancer here and EC3, and we can send our metrics into a CloudWatch. So here's an example here. We can see all our alarms, our logs, and our metrics. This is looking at CPU in a certain instance. You're looking at disk reads and writes and so on. And then we can actually see whether there are alarms, and we can set alarms quite easily based on the data that we have. So any element here, such as network traffic, we could actually set a threshold on the percentage capacity or a certain level of networking. So CloudWatch is a core service that allows us to be able to bring together our core data that we might actually need to watch for. Okay, so we have the EC2. EC2 instances allows us to be able to create compute power. Elastic Container service allows us again to orchestrate services, usually Docker components and so on. These are small service-based containers that allow us to link together to create our system. We then have the registry that allows us to be able to find a place that we define these Docker components, so we can easily go and locate them. And then Beanstalk allows us to be able to scale up web applications using typical ones like Apache and IIS. Okay, so the next unit is security, a big unit, this one here. So it's AWS's responsibility for client-side encryption and also for the physical security inside these availability zones. For security, it's up to the customer to do server-side encryption. So the client side is that's the back end, and then the customer is responsible for the front end infrastructure. They're also responsible for the operating system, networking, and firewall configuration. For security, it's the customer's responsibility to patch the operating system. So if they have Windows 2019 operating system, then they must patch it themselves, and also they must patch they must define the API access for access to resources. For our application, we can have load balancers, EC2 instances, and RDS engines. AWS is responsible for detecting spoofing, packet sniffing, and applying the security patches into the managed database service of RDS. I'll show a diagram of that in a little minute. Customers' responsibility to configure their own infrastructure, of course, but it's AWS's responsibility to secure the physical cloud infrastructure. At the top level is always that the customer is responsible for their own data and not AWS. There's a shared responsibility around patch management for both sides of the cloud and infrastructure, configuration management also, and also to increase awareness and training around security, cloud architecture, and so on. Both AWS and the customer have those responsibilities. The KMS system, the key management system, allows you to be able to create keys in a secure way. It's FIPS 142 compliance, and we can also encrypt data there using our own keys that we generate. There is also a key generation system that AWS provides, but that's their keys that are used on our data. But most of the time we might be using our own keys. We have a root access key. That's the main set of access credentials that we use to log into the management console. We don't normally use them all the time, and we typically create another user to be able to allow us to log in on a more regular basis, and they should definitely not be shared with anyone. They should not be used for any normal accesses from there. Okay, the best practice is that we should rotate our credentials on a regular basis, enable multi-factor authentication, such as using biometrics or using a one-time password approach. We should always review all the accounts that we have and the permissions and policies, and we should go for a least privilege approach. So users get the minimum rights, and or our infrastructure components get the minimum rights to perform their task. And for Secrets Manager, we can use Secrets Manager, and I'll show you that in a little minute. but that allows you to be able to store your database credentials. Amazon Detective is a way that you can actually investigate security events if there's any suspicious activities on AWS accounts. IMA Credential Report gives you details of passwords, access keys, and multi-factor authentication devices that you might set up. The service is used to grant permissions to EC2 instances, and we have AWS Artifact that will allow you to be able to create your compliance reports for auditors. The good thing is that it's possible here to be able to run reports to see all the changes that have happened since the last audit. And an application with the EC2 uses config files that can use config files from S3 buckets. We enable a special IMA role to be able to allow access from the EC2 instance to the S3 buckets. So this is the levels of who's responsible for what. So basically, customer data, always the customer, the platform and identity, operating systems, networks, firewalls, and so on, and then client-side data. And from there, sometimes, depending on the service, we might move that level up and down. But for the core EC2 platform as a service, this is the defining line here. Underneath, it's the responsibility for AWS to look after the regions, the availability zones, the hardware storage, networking hardware, and so on. So this gives you an example here. This is infrastructure as a service, and this is more platform as a service. These are data infrastructures which are managed by AWS mainly. This is mainly managed by the customer. So we can see here the customer is responsible for patching, OS updates, firewalling, and server-side encryption, and obviously the customer data, where if we go over here, then they're only responsible for their own customer data and their data encryption. Everything else is the responsibility, the patching of the system, the firewalling, and the provisioning of the compute power, and so on, is all the responsibility of AWS. Okay, so the customer has more responsibility here, the customer has less responsibility, and it's really a spectrum to understand what service you should pick depending on whether you want a managed service or you want more of a customer-focused service here with more control. Secrets Manager is an interesting area. We can store things like passwords, database passwords in Secrets Manager. So when a database has a password, rather than embed it into the code, when the code runs, it goes to the Secrets Manager and we'll take the password from here and then use that to be able to log in. So this is the Secrets Manager, and it's a great way to make sure your databases don't actually, or the code doesn't actually have any embedded passwords in it. A detective allows you to be able to trail security breaches. It's looking at CloudTrail, your network logs. Guard duty protects user accounts and also into your component logs there too. So from that, it can build up a picture of where there might be some security issues. If we need to implement TLS, HTTPS, and so on, then we need a certificate storage, and ACM allows us to be able to create public certificates, private ones, and then we can import certificates in here. This allows us to be able to integrate our TLS services into our infrastructure. Cognito allows us to be able to create federated logins. We could use Facebook, Twitter, Google, and so on, and get tokens from there, which are then trusted into our infrastructure, and then that gives us rights into our AWS infrastructure. So that's Cognito. So ACM, as I said, creates SSL TLS certificates. Guard Duty is a service that allows the analysis of user type logs, especially from CloudTrail, to be able to see if there is any suspicious things going on. It will typically look at S3 logs, DNS logs, EBS data logs, and for RDS to see if there's any suspicious activity going on. A WAF is a web application firewall, and it typically sits in front of the infrastructure and protects against denial of service, SQL attacks, and so on. So our main server might be here, but we put a WAF here, and the WAF breaks the encryption tunnel and then can examine the traffic before it gets to the end server. The best practice for AWS management console is to enable multi-factor authentication and also implement a very strong password policy. So here is Guard Duty. So Guard Duty is there to continually monitor the logs that we have to see if there are any suspicious activities. Our WAF, the WAF integrates in with our backend infrastructure with CloudFront load balancing, our API gateways, and so on. And in here we configure policies that can examine the traffic and look for SQL injection, attacks, denial of service, and so on. So there is more of a deep packet or an analysis of the packets within the WAF to allow us to be able to deal with any attacks at the front end rather than for them to get to the back end infrastructure. AWS Shield is an important service. It protects against denial of service and can obviously be integrated into our firewall manager and also into our WAF. And as part of that, it's important, one way to cope with denial of service is with elastic load balancing. So Shield integrates in with that back end to be able to spin up other instances as we're being attacked, so that customers don't feel that they are disadvantaged. Artifact allows us to be able to store all our reports that we need for auditing purposes for our auditors, and we can accept and agree changes to our system so that when auditors come in, then they have that trace of our documentation. And then there are 4 basic plans. The admin account can change each support, but obviously cost different levels. Basic support, for that we have developer support for developers, business support, and then at the top level we have enterprise support for mission critical workloads. So the next unit is networking and content delivery. So with this, our VPC provides our basic networking infrastructure. DNS, our Route 53 provides failover. Whenever we have a web server outage, we can automatically detect it and redirect it to another place that doesn't have an outage. Our availability zones are isolated from each other, and the data centers are contained within regions and are isolated geographically from each other, but have low latency connections so they can synchronize very quickly. We create our isolated environments with separate VPCs that have each of their own different subnets and then link them together. A VPN can be used to be able to create an encryption tunnel if we require between our infrastructure and remote connection. A local zone extends an AWS region, but gives us more granular location information to allow even faster connection times. And a region is a physical location in the world which has a clustering around these data centers or availability zones. And network ACLs and security groups define the security between subnets. So Route 53 does DNS monitoring, does DNS lookups where it's possible to resolve a domain name into an IP address, and we can do health checks in there to make sure that the domain service is running okay. And all our logs can actually go into CloudWatch to make sure that we can actually identify popular routes and any problems. Module 6 is compute, and this is where EC2 comes in, and this is where we have elasticity to be able to eliminate underutilized CPU, and also to connect our customers into into regions for low latency and high throughputs. And also we have redundant infrastructures where if one region was to fail, then it wouldn't really affect too much our provision. Elasticity allows us to be able to get the right size of our resources for the demand at any given time, and release our compute power when it's not really needed, but also get it back when we need to scale up in again. EC2 auto scaling allows us to automatically scale in and scale out with our instances based on the demand. Spot instances are good for being not expensive, and these allow us to be able to use compute power for a short period, but they may be interrupted at any time. So with a spot instance, we could buy a spot instance, but it may actually be stopped as the computing power is required by AWS somewhere else. So these are good for stateless applications, such as in batch files and so on, that we might do some computing power, and it doesn't matter if it's been interrupted, we still have the results up to that point. On-demand instances is what we normally use, and we just require, they're fairly cost effective, and the customer defines when they're stopped, hibernated or terminated. So with a serverless approach with Lambda, we can have built-in fault tolerance, and we can also have applications that scale on demand. Auto scaling allows us to very quickly scale up, scale in and scale out. And if an instance needs a license with, say, a certain number of cores, we can use a dedicated host for that. If a company runs a data processing application for just a few hours a week, then AWS Lambda is a good choice for that. For a website that needs to be run continuously, then we probably want to be reserving instances and using a savings plan, such as for 1 or 3 years. Lightsail is a virtual private server, and AWS supports the running of multiple AWS batch supports the running of multiple batch files. So as I said, we can have on demand, pay per hour, no long-term commitment. These are the normal instances that we create. A dedicated host is a physical server which is only used by a specific customer. Dedicated instances run on hardware that's dedicated to one customer. Reserved instances, you can then purchase the computing power for your scheduled activities, typically for 1 or 3 years. And spot instances allows you to purchase compute power when required, but it may be interrupted, and you get it at a spot price. For storage, we have the elastic file system, and that allows us to be able to share our files across multiple EC2 instances and across regions. S3 allows us to be able to store object files into a low latency storage area that is virtually unlimited in its scaling at a very low cost. S3 and RDS database allows us for cross-region replication, whereas EBS, the disks that we typically mount onto EC2, are replicated across availability zones, but not across regions, quite rightly. By default, EBS and Redshift are available across more than one availability zone. Ephemeral storage is used as a temporary storage place, and it's very fast. Elastic cache is an example of this type of storage. But when we take the power away, we will lose all of our storage. So EFS, we can mount onto multiple instances. S3 is persistent storage, and we have a URL to be able to identify where we can actually get the data. And if you change a single file in block storage, it changes one little block. But if you change a single character within object storage, it will change the whole of the object. A snapshot is a backup of an EBS, and we only get charged for the extra little bit of the data between the last snapshot and this one. And SSDs are faster than for HDs. So these are the databases. Aurora, RDS, and Redshift are relational databases. They do data infrastructures at scale, at an enterprise level, but they are fairly fixed in their structure. A more dynamic one is to use key value or no SQL. We can have in-memory databases with elastic cache, and these are some of the other ones there. Okay, so for storage, for disaster recovery, we make sure that we have snapshots that can be copied into different regions. If our disks fail, then we can actually recover the data from the snapshots. Data encryption doesn't cost anything. The basic costings for ECB relate to the input-output operations, the volume size, and the volume type. Bucket names are universal across the AWS cloud and must be unique for every data buckets. 5 terabytes is the maximum size of an object in S3, but we can have almost unlimited storage. With S3, the data is not public by default, and we must enable it to be public, and then we're typically limited by time for that sharing. S3, high durability, availability, and performance of object storing. We can also have different tiering architectures for S3 to allow for data transfers and so on. And S3 Glacier allows us to back up our data onto more long-term storage, which is cheaper, but the latency is much greater than the normal S3 buckets. There are 2 ways that we can manage the keys. We can have our own key that we provide through KMS, or we could use the generic Amazon S3 provided key to encrypt our data. Okay, so here's the 2 key options when we're creating our server-side encryption for our S3 bucket, and this will allow us to be able to find the key that we're going to use, and we can actually provide our own key, or we can go for the generic S3 key that Amazon provides. For databases, elastic cache in memory, if we very, very, very fast, but then if we take the power away or the system was to be terminated, then we lose the data. DynamoDB is a NoSQL with JSON key pairs. We have the customers responsible for encryption of the database. Aurora, responsible for MySQL and PostgreSQL. As I said, Dynamo is a NoSQL database approach where we can add columns, where in a relational database it's very difficult to change the basic structure of the data infrastructure, the schema. RDS is an enterprise level database, and it's not fully managed by AWS. Aurora is a relational database at enterprise level, and it is managed by AWS. Redshift is good for data warehousing and big data applications. It also supports MySQL and PostgreSQL and Oracle too. MySQL and Windows servers are useful for that, but it's possible to, and we would use RDS when we're migrating from MySQL and Windows servers. Again, Oracle and MySQL, we can use our Amazon RDS for that migration. An unmanaged database is something like our RDS, and it allows us to be able to manage, the customer manages the database, where a managed service allows it to be managed by AWS. Okay, so here is the infrastructure, here is RDS, and you can see the customer has more control over there, and in some cases we can create our database inside EC2 to give us more control there. But if we use DynamoDB, we can see that AWS has the most responsibility here, and we just have the customer data and the client-side encryption to deal with them. Okay, we can migrate from on-premise into the cloud using our migration service if we need to be able to discover our data, convert it, and then migrate it. When it comes to cloud architectures, reliability is important to be able to recover from failures, and we, as much as possible, we want to automate that. So it's a key factor that there shouldn't really be much automation when it comes to the fixing of the cloud infrastructure, and it very much moves away from the need to guess the capacity that's required. Operational excellence is for continuous and small changes in the way that we deliver, and to be able to reflect that in the business processes that we have. Security, so this is part of the well-architected framework. Security allows for the protection of data, systems and assets, and improve the overall security. Performance efficiency is another part of the well-architected framework, and it supports the efficient usage of the services to make sure that we meet the demand, and also for technological changes. Cost optimization is to find the lowest point that we can to effectively deliver our business value. And sustainability is, of course, about the reduction of energy costs and improving resource utilization. So it's very important for the certification that you understand each of the different areas here: operational excellence, security, reliability, sustainability, cost optimization, and performance efficiency. Those are the core principles of the well-architected architecture framework. And finally, we get to automatic scaling. Elastic load balancing allows us to be able to cope with changes in demand, to move in and out. We have three levels of load balancer application. Load balancer works at layer 7 for HTTP and HTTPS, and our network load balancing works at the TCP and UDP layer, where we can also have a classic balancer which does all of it together. It's not recommended. We would normally go with an application or a network load balancer overall. Listeners are required to be able to make our load balancing work efficiently from there, and that's that. Okay, so our load balancing network load balancer will typically work with an elastic IP address that we apply, or for an IP address outside our VPC. So for the monitoring, to make sure that we understand and can troubleshoot and so on, we will use CloudWatch and CloudTrail along with other Amazon logs to make sure that we debug any problems with these things. Within CloudWatch, as we saw earlier, we can monitor CPU, networking, disk operations and charges and so on, and then use that to effectively scale and monitor our cloud. Auto-scaling group is a group that allows the EC2 instances to be treated as a logical group together, and they can be managed together for the scaling. And as I said, to cope with an increase in demand, we scale in, and to cope with a decreasing demand, we scale out. We can use the simple notification service to be able to make sure that we can alert through messaging. The simple email service allows emails to be sent from CloudWatch, and we can also use the queuing system to be able to decouple our applications. So this is CloudTrail here, and we can see that CloudTrail is taking lots of logs from many different systems and then bringing them in to be able to analyze where there has been movements of user activity. Okay, so that's been a brief introduction to the AWS Certified Cloud Practitioner. Thank you.